Hello everyone. Let us now discuss today's LeetCode POTD problem. Question number 2415. Reverse odd levels of binary tree. So in this question, we are given with a binary tree. So the the levels where we are having odd, so this is an odd level, this is the level 1, and we are having this is the odd level, so we need to reverse them. Let us take an example for this question. 2, 3, 5, 6, 13, 21, and 24. So this is the odd level, this is the level 1. Now we will be reversing that. 5, here 3, and 6, 13, 20, 21, 34. Sorry, here it is 34. Now we need to return this root node of this reconstructed tree. So this is quite a simple problem if you know somewhat of a BFS or DFS algorithm. Let us go with another example. Now we are given with 7, 13, 11, and here this is the level 1, which is odd. So 7, we will be reversing these nodes. So 7, 11, and 13, we will be returning this root node. So if you see clearly, we are going for odd level. So that means we need to do a breadth first search for each level. Now, this is the thing, this is the first observation. So, let us take an example. This is level 0, this is level 1, this is level 2, level 3, level 4. Let us take a tree, level 1, this is level 3, and this is level 4. So, so here in this case, if you are at level 1, we need to take this and reverse them. If you are level 2, take this but in the same order. Here we are at level 3, which is odd. Take these all elements and reverse them. This will be coming at the first, this is the second, this is the third, and this will be at the last. That means we are reversing this all the elements when we got an odd level. So the first observation is going for level by level for odd level. Now we need to get odd level, so we are using a breadth first search algorithm. So the first algorithm or first intuition we got is BFS algorithm. And what will be the whole algorithm for this question? So let us take one example. Let us go through this algorithm. The first thing which we do is taking all the levels, so this is level 0, this is level 1, this is level 2. So these are the levels stored in vector of vector int. No, we need to store all the levels in our vector of vector int. Now the thing is, we need to do BFS breadth first search. So we will be using a queue which takes tree node. Now in this tree node, we are having at the first level, we are having level is equal to 0. So the first level will be 0, and then We need to, as I said, we need to do a breadth first search algorithm. While queue is not empty, search for search for the nodes for this for the top element. Now size is equal to q dot size and vector int level vector. So this is the level vector which stores all the levels, all the levels, all the levels of the tree. This is the first level and this is the level 2. This is level 0. This is level 1. Now we are constructing a level vector. That means for every level we will be using this vector for the elements in that level. Now we will be running a loop 0 to size of the queue. Now the current node will be the toppest, sorry, the front element, sorry, front node in the queue. And after taking that, we need to remove that from the queue. And then, as I said, we will be pushing or storing all the elements of the current level into the level vector. So store the current node's value in the level vector. Now if you have a for the current left for the current, so take into consideration for q. Same with the right node. If you have right node, consider that too. And after that we'll be getting another thing is, that is, if you are having, if the current level, if the current level is odd, that means we need to reverse our vector. So if level percentile 2 is equal to 1, reverse level vector. So we will be reversing this level vector. And after that, if only the, or if the level is only odd, then only we will be reversing our level vector. And then levels dot pushback level vector. And after every iteration, after every taking of every node, we will be incrementing our level. So after this, we didn't go through the construction of a new tree. That is construction of a new tree. So we are having a levels vector of vector. So the thing is, the first node will be new root. The new constructed tree will be having named new root is equal to new tree node. The first thing will be levels of 0, 0. Now we'll be taking another queue. For this, traversal, new queue dot pushback, sorry, push new root. We'll be going through the same algorithm for int I is equal to 1 to levels dot size. That means if we are having these levels for level 0, 1, 2, so we are iterating through these levels, level 0, level 1, level 2 with I. And now index is equal to 0 and level size will be levels of I dot size. This is the size of each level. Now while index is less than level size and new queue is not empty. The parent node will be new queue dot friend, and after that take out the new queue. If the index is less than level size, then parent left is equal to new tree node levels of I index plus plus, and push back our new node parent left, and do the same. That means if we are having in this like 1 2 3, you are having this element, and you are having this next element. That means we need to go through left, constructing of left, and as I said, index plus plus, that means we are at this index, and even if that is not equal to the level size, we need to go through another element and push back into our right. So parent right is equal to new tree node levels of I index plus plus, and new queue dot push parent right, the right children of the parent. And after the construction of the new tree, we will be returning the new root. So this is how you approach the problem. If you like this video, share to your friends and subscribe to my channel. Thank you.